Hi class, we're going to talk about FTK today, the Imager. The forensic toolkit is FTK. It's a computer forensic software application by Access Data. The toolkit includes a standalone disk imaging program called FTK Imager, and it's free tool that will save an image of a hard disk in one file or in different segments. That may be reconstructed later. It also calculates your MD5 and SHA1 hash values of the original copy so that you can confirm the integrity of the data before closing the files. Okay, so FTK is used to produce a hard disk image, and it can be analyzed by forensic software. So in forensics investigations, they work with image files because they can be examined without damaging the original evidence. So you actually want a duplication of the original. You never want to work with the original data. So bitstream imaging is the process of duplication of that original data on storage devices for the forensic analysis. So you can capture RAM and swap with FTK as well. So Imager can create forensics images of your local hard drives, floppy disk, if there's still some floppy disk out there, zip disks, CDs, DVDs, thumb drives, entire folders, or individual files from various places within the media. You can preview the files and folders on local hard drives, network drives, and so forth. So it also includes files located in container files, such as a zip or RAR files. And you can preview the contents of those images stored on the local machine or on a network drive. You can also mount them for read-only view, and it leverages Windows Explorer to see the content of the image exactly as the user saw it on the original drive. And you can export files and folders from the images, and you can also recover files that have been deleted from the recycle bin but have not been overwritten on the drive yet. Remember, when you delete something, it's not actually deleted. You can still recover it unless it's completely overwritten. And then when it is overwritten, there's some pieces maybe still around that can tell you that there was once a file there. All right. Like I said, it can create MD5 SHA hashes of files, generate hash reports for regular files and disk images. And then you can later use those as a benchmark to prove the integrity of your data for your evidence. Okay. When a full drive is imaged, a hash is generated by FTK Imager, and so then you can verify that the image hash and the drive hash match after your image is created. And then what you would do is actually take a copy of that image and do not work with the original. Like all forensically sound collection tools, FTK retains the file system metadata and the file path. So metadata is data about data. So it gives you some information about what you have collected, and it creates a log of the files that are copied. You can also provide a case number, evidence number, unique description by giving it some what is it called? Properties. Properties are for that particular data is that metadata. Okay, So that'll just aid you in tracking purposes, to aid in any kind of chain of custody tracking, if have you a need for it. To download FTK, get the FTK Imager, not the toolkit, and you can go to Access Data. You guys probably have already installed it, and we're going to talk about RAM and swap at this point. We're going to be using FTK for a lab later on in this for this week. All right, during an investigation, you always want to create some kind of forensic image. So that means a clean image, it hasn't been tampered with, and you want all the relevant computer systems that are involved as well. However, what if you encounter a live system? So the random access memory, or RAM, is a form of computer data storage that allows information to be stored or retrieved on a computer. So because the information is accessed randomly instead of sequentially like it is on a hard drive, the computer can access the data much faster. One of the downsides of RAM is that it requires power to keep the data accessible. So as soon as you turn the power off, then all that information that's stored in RAM is lost. So all programs running on your system are storing data in RAM, and you can imagine how much evidence the RAM may contain. Some examples of the information that may be stored in RAM include your chat sessions, internet history, email, including webmail, encryption keys, username and passwords, and documents. So there are a few tools out there that are able to create an image or a dump of system RAM, and some of those are Belkasoft Live RAM Capture, FireEye, Memorize, Results or Dump It, and Access Data FTK Imager. So we'll focus on the Imager. So this is what it looks like when you open it up. After starting FTK, this is your main window. You can open the menu with Alt-F, or just go into click on File and choose the option to capture memory, or you can use an Alt-T command there. So you want to choose a destination for your image. Okay, so you always choose an external path, like a USB drive or external hard drive, but you never want to store the image on a live system. Otherwise, you end up modifying the evidence. But a lot of times you'll have some kind of write blocker if you're trying to capture an image off of a live computer, so you won't leave any trace behind and mess with the image. So, like I said, you never want to store your image on a live system, otherwise you end up modifying the evidence. And keep in mind your image is going to be slightly bigger than the total amount of RAM you're going to capture. Now, we want to capture information from a USB drive, then for our lab, we are going to have to store it on our desktop. Okay, you don't want to store it back on the USB, only because it will keep recording and it'll get you in a loop. Okay, so when we use our USB or thumb drive, our destination path is actually going to be on our desktop, and then you can name your destination file name memorydump.mem. I don't think you include the page file. Let's see. If you include the page file, I think it's going to make it larger. Okay, and we will demo this upcoming lab as well. So FTK gives you the option to include the page file and to create an AD1 image. Including the page file might be interesting. Outside the additional time it takes, there's no real reason to capture that page file. The page file is a great addition to the memory dump, however. Creating an AD1 file is recommended. The AD1 file will contain the memory dump and the page file if selected. The 81 will be compressed and take up less space, plus it's hashed, and then for obvious reasons, the 81 file helps keep the image forensically sound as well. So after selecting your options, you can press Capture Memory, the Capture Memory button, and the capture starts. When it's done, it will give you a message, then you can close the program. You can use the image in your favorite investigation tool for analysis. Okay.